Has this ever happened to you, falling down a hill while hiking? Well, this is the question that got us thinking about what type of shoe has the highest coefficient of friction to prevent this from happening in the future. Would it be smart to hike in cowboy boots? I wonder what the coefficient of friction for that type is. So, a 1.225 kilogram shoe, the cowboy boot,
Which
is
we
sliding,
found by taking the mastering class.
we
So
weighed
did
it,
that.
down a 0.54 meter hill. We measured that with a yard, whatever you call it?
Yardstick.
Yeah, yardstick. At 28.8 degrees, we found that through trigonometry, with an acceleration of
Oh wait.
this.
Yeah.
We had
1.5.
approximately 1.5 meters per second squared. We were able to derive that because
we looked at the video, looked at the final velocity, and calculated approximately over the time
what the acceleration was. And so what we're trying to find is the coefficient of friction. So, oh shit, what did we do?
It's a dynamics problem.
Oh,
no.
Okay, now I know that the vector sum of the forces equals mass times acceleration.
So then the first thing we do, we draw a free body diagram. Here's our object. This is the shoe. We have the force of gravity. We have the normal force, keeping it on the hill because this is the hill. And then we have the force of friction because we know that it is accelerating this way. We see that in the video, so we know the force of friction is in the opposite direction. So we're going to turn our axes, make this the x direction. This is the hill right here. Make this the y direction. We know the acceleration then is all in the x direction. That makes it a lot easier. So then we know that the force of gravity, this is the force of gravity right here, and we're going to split it into the x and y components because only the x component in this case is contributing to acceleration. So we split it up. We know that we're given that this is 28.8 degrees, so we know we can calculate that this one is 31.2. Then we're going to use our trigonometry again to find the x and y components of gravity. So
over here
we did that. Sine and
calculations.
cosine. This is the 6.35 newtons is the force in the y direction, and 10.45 is in the x direction.
Okay, so from then I was like, okay, conceptualize this. I have my two equations of force. So I have my force, the sum of the forces in the x direction, the sum of the forces in the y direction. The sum of the forces in the x direction is the force of gravity in the x direction minus friction, which we know is not in equilibrium because there is an acceleration down the hill. Then we have the forces in the y direction, which is the force of gravity in the y direction minus the normal force, which we know is in the equilibrium because the shoe is resting.
The shoe is not falling
the hill.
into the hill.
Yeah, exactly. So from there, I was like, okay, what am I even trying to look for? Oh yeah, I'm trying to find the coefficient of friction. And we know the equation for friction, kinetic friction, is the coefficient of kinetic friction times the normal force. So I'm going to start by trying to find my normal force. The way I found that is if I know 0, because we determined that it is in equilibrium, equals the force of gravity in the y direction minus the normal force. If the force of gravity in the y direction is 6.35, then I know that the normal force is also 6.35.
So perfect. So Maddie found the normal force for us. So what else do we need? We're trying to find the coefficient of friction, so we changed our equation to be set to that. So now we just need the force of friction, of kinetic friction. So we calculated that because we know that the sum of the forces is mass and acceleration. We know the acceleration in this direction. We know the mass, and now we just need to find the sum of the forces in that direction. So we plugged all those numbers in. We found that the sum of the force is in the x direction is 1.84 newtons. And then we
set that back over here. We have our equation for what the sum of the forces in the x direction are.
So we
know that
we know
total,
that,
and we know that. So then we were
solve
able
for
to
the
find
friction.
friction.
And then we're going to just put that right back into our equation to find the coefficient of friction. So we have our force of friction, our normal force, and our final coefficient of friction is 0.383.
Which is pretty realistic. We looked it up. Really good shoes and concrete can be anywhere from like 0.5 to 0.8. And so that is pretty low. So
these really do not have
I
very
don't think
good.
I should hike in cowboy
I think that's
boots.
probably a smart idea.
I think that's the decision.
I think that was what physics taught us.
Physics, thank you.
So
Pretty
clearly,
accurate for trail.
these are not the best shoes to be wearing hiking.
You look pretty
I mean,
fashionable,
I
though.
think it's a good look, Maddie.
I mean, it's a good look, but too bad it doesn't
Too
work
bad it's
out.
not the best
Darn
with
it, physics! You had to ruin our fashion. Okay.